Hey gamers, what's up? Guess what? I still haven't gave up on my survival game for the NES, and I'm still slowly but steadily working on it. So what's new? Until now I only had this tiny map that was just 2 screens wide. As I mentioned in my last video, I needed to make it way bigger. So it would be interesting to wander around it, collect stuff and kill some critters. When I started to think how it might be done, I realized what a dummy I was. I actually needed to implement a decent scrolling way before I started toying with collision detection and the items. Now it will possibly mess everything up and nothing's gonna work. It's like you already built a wooden house and then suddenly say, I need brick walls. Well, good luck keeping the roof and other stuff intact while replacing those walls. But I guess stuff like that happens all the time in the software development, right? As we know, the NES can only hold 2 screens in its 2 kilobytes of video memory. So how to display and scroll more than that? If we look closer at Super Mario Bros. Using the name table viewer in the FCUX, we would notice the game updates the name table B column by column, and then starts gradually updating name table A, and then goes back to B, and so on. At first it was hard to imagine how to reproduce that in my game. The 8-bit screen scrolling value could be in a range from 0 to 255. If we would try to scroll past the second screen, we would be immediately teleported to the first one. And that's because if I increment 255 by 1, it will automatically fall back to 0. So how the heck Mario does this transition between the second and the third screens? Apparently we can tell to the PPU which screen is the first one by changing the lowest bit in the PPU settings and sending them to the address 2000. If that bit is 0, the name table A is the first and B is the second. But if the bit is 1, then the order is reversed. Basically we need to do that when we reach the maximum scrolling value. When the scroll value reaches 255, we must flip that bit, and the screens would switch places noticeably. And if we would increment the scroll value after that moment, we would see the next screen appearing. So that's great, but now I somehow need to upload new values to the name tables while the map is scrolling. Before we start messing around with the video memory, we need to know how it's organized. I think I've mentioned before, the single NES screen is stored in 1 kilobyte. Each tile is a single byte. Since the screen wide is 32 tiles, 1 row is 32 bytes. Multiply that by 30 rows and you will get 960 bytes. Wait a sec, but the kilobyte is 1024 bytes. What about the remaining 64 bytes? Well, those bytes are used for so-called tile attributes. That's the information of what palette a 2-on-2 tile group will be using. Imagine the NES screen divided into groups of 4-on-4 tiles. A single byte in the attribute memory stores an information for each of those groups. As we already know, there are only 4 different palettes for the whole background, so we can perfectly fit 4 different values into 2 bits. The byte is 8 bits, so in that byte we can store 4 palette indexes. So we have 8 columns and 8 rows of those bytes. That's 64 in total. Okay, now I know the video memory's layout. Now I need to determine what map column I need to update. At the beginning, in order to calculate the index of the column, I simply divided the scroll value by 8, since the tile wide is 8 pixels. So using that column, I would calculate both addresses in the video memory and in the ROM. I would read a byte from the ROM and send it to the PPU. Then I would increment the lower address by 32, send the new address to the PPU, and then I would write the next byte in the column, and so on. But it didn't work as I expected. Constantly changing the address for each column cell manually is, well, apparently it's too slow. But how the heck Mario is doing it? To properly write column values to the PPU, we need to change the addressing mode by changing the third PPU setting bit to 1, like this, and send it to the address 2000. This way, after writing a byte to the video memory, the address would be incremented not by 1, but by 32 automatically. So this way, only the single column would be updated. After I managed to update my tile column, I've noticed that the tile colors on the screen are not quite correct. And that's because we also need to update the attribute values. Let's try to write 8 bytes to the PPU for a single attribute column. Note that each attribute byte will affect colors in 4-on-4 tile groups. So I somehow managed to update my map while scrolling to the right using this simple algorithm. If the scroll value is between 0 and 128, I would update columns from 16 to 31 in the name table B. Then at the scroll values from 128 to 255, I would update name tables A columns from 0 to 15. And when the scroll value would reach 255, I would flip the screens. So the first screen would become the second. And then I would repeat everything again. Also, I've decided not to update upper 2 map rows, since the very first is not visible anyway, and if I update the second, I would destroy the status bar. While working, I've encountered some weird issues with my maps. I noticed that by writing more code, some sections of my map on the screen got corrupted, even if I wrote a bunch of NLPs. What the heck? What's interesting that by adding even more code or moving the map data around fixes everything. So I suspected that it happened because the map data was not aligned to the PRG's ROM's pages. Because I had the exact same issue while developing the Atari 2600 game. My final solution to this problem was to move the ROM's data before the code in the assembler's memory configuration file. So this way it doesn't really matter how much new code I add, the data stays in one place. After many attempts and failures, I got scrolling through 4 screens while moving both ways. Although there was an annoying issue where some columns were not updated or updated incorrectly. Surprisingly, my collision detection worked pretty well with the new scrolling. There was only a minor sync issue where the collision used to shift few pixels right after the character would go to the far right end of the map. But I managed to fix it fairly easily. I had to fix the menu and title screens though. Unfortunately, there weren't some huge sprites that temporarily floats above your stuff like in modern systems. I actually need to recreate every tile after those screens are closed. It was a funny surprise that those screens did not show up when the first and the second name tables were flipped. So for instance, if the player died, the title screen would not appear. But if you turned the name table viewer in the FCX, you would see that the title screen is actually there, but it is written to the wrong name table. Another issue with my scrolling was that, well, my code was too slow and took too much time to execute. I've already mentioned a couple of times that the NMI has a very limited time to do some PPU updates. In my case, the tile attribute and HUD updates took too long. On the emulator, it just caused some screen jumping. I thought that everything is alright and it's not a big deal. Meanwhile, on the real hardware, it caused some extreme glitching and even the game got stuck a couple of times. And that's because the NMI is activated during the vertical blank period when the PPU is inactive. But if your code executes too long, the PPU becomes active again and weird things might happen. Probably the easiest and maybe hackiest way to reduce glitching was not to update the lowest tile attribute row. Plus, I skipped the tile value row at the very bottom of the screen. This one's also not visible. Then I thought, well, the map looks kinda dull. let's make it more interesting to look at. So I added the fifth screen and drew some new tiles. While doing this visual update, I got tired writing manually ones and zeros in the collision data maps. So I decided to start making my own map editor where I could edit tile placement, collisions, and various entities simultaneously. Yeah, I know that's probably a dumb idea, but I really wanted to do that. I grabbed an old 2D map editor that I made like 15 years ago for some dumb game of mine. I stripped most of its features except the single tile layer and the collision grid layer. I replaced the previous tile set with tiles that I exported with Screen Tool, and boom! I could finally edit collision data in my own editor. When I click this floppy icon, I can write the assembly data to a text file. From that file I can copy the data to my collision data code. It was a fun distraction, and I think I will be improving the editor bit by bit in future. Now when the map became more varied, the annoying issue where some of the columns are not updated correctly became even more noticeable and much more annoying. But what actually caused this issue? After some searching and debugging, I realized that was happening because I used the characters direction to calculate map's index, from which I copied the tile data to the PPU. Everything would be fine until the moment the character would move down. Then the direction would change and the wrong data would be written to the active column. So after this discovery, it was very easy to fix the issue. The final goal was to load the correct tiles after the menu was closed. Until that moment I would simply load 2 map screens to the video memory. But this would eliminate the map's column updates that I did while the character was walking. So after closing the menu and walking forward, you might encounter some weird tiles that are not supposed to be there. My solution was to load additional map fragments on top that are calculated depending on the scrolling direction and the active map column. I think it actually worked. The name table viewer was a very helpful tool here, and I wish there was a shortcut key to activate it. I skipped loading attribute data for those fragments though. I don't know, I was kinda tired. So after using the menu, you might find some colors on the map are not quite correct. I will try to fix that sometime later. So I've achieved what I wanted. Now I can add more maps to my list and scroll through them horizontally. The only limit is the PNG's ROM size. By the way, I still have 18 kilobytes left. Of course, we only have the horizontal scrolling, but I think it will be good enough for now. Maybe I will try to implement the vertical scrolling in some distant future. So let's move to the next thing I need to accomplish. According to my development roadmap, that is to spread the items across entire game's world, so they are not just in the first screen. Also, I need to spawn some moving entities that could drop items as well. Will I manage to do all that? You will find out that in my next video, so subscribe and hit the bell icon so you won't miss my updates. As usual, the links to my Git repository and the latest ROM are in the description. So, that's it for now. Thanks for watching. See you next time. Bye!